Hi students, Miss Walsh here. Okay, today we are going to solve exponential equations, and we're going to use our knowledge of solving equations, and we're also going to use this idea of logical equivalence, okay? And this statement right here says that if you have a to the power of x and a to the power of y, if it's the same base, that means that those exponents must be equivalent, okay? And this is the central idea for today's lesson. It also works the other way. If you have two equivalent terms, then you can take them to the power of the same base, and that equivalence will be maintained, okay? So let's apply this. So we have here 5 to the x, and we have 25. So we're going to express it with the same base. That common base is that idea for today, okay? So this is going to stay as 5 to the x, and I'm going to express 25 as 5 squared. I now have the situation where I can ignore the base, okay? So we ignore the base now, and that means that our answer is going to be x is equal to 2. Okay, let's try another one. So here, what will be our common base? It's always something simple and basic for our purposes, okay? And it will always work. We'll always be able to find that common base. Questions that we can't must be solved with a different technique called logarithms, if you're interested. Okay, so here I can express 16 as a base of 2 as well, can't I? So if I just start listing my powers of 2, we have 2, 4, 8, 16. So 2 to the power of 4 will give me this 16. And I can then use my law of equivalence. And now we ignore the base and we just solve it as a regular equation. Take 1 off from both sides, and this will be our result. Okay, let's take a look at the next one. Okay, so just decide on what your common base is there. And here you can see, okay, 3 is here. Can I do this? Can I express this as a 3? Yes, I can. Remember the negative rule, right? So 3, 9, 27, that will work. And then it's just going to have to be negative in order to change floors to come up to the numerator. Okay, minus 1. Okay, I can now ignore the base, and my equation is x minus 1 is equal to negative 3. Add 1 to both sides. And what we have is we have x is equal to negative 2. Now, if you wanted to, you can, of course, check. Let's just check. So let's take this negative 2. So we're going to check. Okay, and we have 3 to the power of negative 2. Negative 1 is negative 3. And there is my 1 over 27. So it works. Okay, this one. If I were to try to express this with a base of 4, the problem is as soon as I start listing the bases of 4, we're already over, right? So 4 is not going to work. So we're going to need to use 2. Okay, so we're gonna, this is different because before this we were just applying this to one side, and now we're actually going to have to change that base on both sides. Okay, let's start with the right side, it's easier. So 8 is 2 to the power of 3, and then keep the exponent that you have, keep it on the outside, we'll simplify in a moment. And then 4 is 2 to the 2, and then this is x minus 2 is still there. Okay, now I'm going to expand, so multiply it out just like you would with your regular algebra rules. So this is 2x minus 4, Notice, because the 2 has to be expanded. And then this is going to be 3 times x. Okay, so now I have my equivalence statement, so I can ignore the basis. And now I'm just writing it, the equation, in terms of the exponents. Okay, we're going to take 2x off from both sides. Just to bring the x's together, just regular algebra. And we have x being equal to -4. All right, last one, okay? All right, so we have a quarter and we have 8. Again, 4 is not going to work. And so what we're going to do is we're going to use 2. And sometimes I actually like to write a little CB, what my common base is. Okay, so let's start with the right side again. Okay, so we already know this is going to be 2 to the power of 3. Okay, now a quarter. The 4 is squared. So this is going to be, but it's on the bottom. So to bring it up, this is going to be 2 to the -2. So 2 to the -2 is a quarter. And then we have 1 minus x. And now we're just going to expand this. And we have 2 to the power of -2 plus 2x. Careful with the signs there. And then on the right side, we have that 3. Okay, equivalence, drop the bases. And we have -2 plus 2x is equal to 3. And then 2x, add 2 to both sides, is equal to 5. And so our x is going to be 5/2. Okay? So just a little bit of using our exponent rules to solve the regular equations and using that beautiful equivalence law. Okay, bye.